Good afternoon and hello again, ladies and gentlemen, and welcome to the next session of the technical webinar series at BEX Asia Digital 2021. This session will be hosted by beez-fm. My name is Henry and I will be your MC for this next session on the topic of building management solutions. Before we begin though, I would like to encourage everyone to send in any questions as we go through the session via the Q&A tab at the right-hand side of your screen. Questions will then be addressed towards the end of the presentation during the specific segment. Please also refer to the poll questions on the right-hand side of your screen now. There you will see 3 questions. I would like you to please view question number 1 and submit your answers, as we'll be revealing those and discussing those very shortly. Today's topic is titled The Unsuspected Capabilities of a BMS in 2021 and the Misconception in Asia. I am delighted to welcome our speaker from beez-fm, Mr. Nicholas Zalter. He's the Managing Director. Nicholas, who is also head of Sauter APAC, that's 1T, has an IT and marketing degree. He started his Sauter career in the head office in 2008 and has been the management solutions product manager for several years. After a successful new product launch in Europe, he started as marketing manager for the whole of the APAC region in 2015. He then relocated himself in Shanghai for 20 months to be closer to the markets before moving to Singapore in 2018. Strong from his experience in Europe and Asia, he still witnessed too many instances of decision makers favoring unreliable, cheap devices coupled to outdated building management systems design in order to keep CapEx investments to a minimum. This always results in a significantly reduced building efficiency, increased OpEx, and unnecessarily high carbon footprint. To solve this economic and environmental issue, he has created beez-fm, and we'll be sharing more about their offering with you today. Nicholas, if you'd like to turn on your camera and microphone, please, and join us. And before you begin your presentation, I will just quickly flick over to see how the poll results are looking so far, and perhaps offer you to give some comments here. So your first question was, before the start of this webinar, what was for you the role of the BMS supposed to be in the building? The options were advanced chiller plant room control, managing AHUs in addition to plant room, or control of lighting, cooling, heating, blinds, doors, access, and much more. 2/3 of our audience have voted for option 3, which is in control of lighting, cooling, heating, blinds, doors, access, and much more, with about a split vote from the other 2 options. So with that in mind, I will hand over to you for any commentary. And then once you're ready, please begin your presentation for us today. Thank you.
All right. Thank you very much, Henry. That's a first very interesting answer to the question, because most of the time when we are here in Singapore and Southeast Asia, even more, you see that building and BMS are not understood this way, but I'm very positively surprised by this answer. And so, yeah, I will share with you my presentation and what is for me. Actually, that's a very good introduction to the topic, because what's for me a BMS in 2021? I mean, that's the question which I would like to try to answer first. And yeah, let's show this. And if you have any question also, as Henry said, we are looking forward to answer them as well. All right. So, well, beez-fm is providing BMS as a service solution. But before to get into that and to show what's our offering, I just wanted to base this topic more on what a BMS should be in 2021. So before to address that, there's just a point I wanted to mention again, is in the BMS market, we have a very big issue, because we have customers. So we have building owners who are most of the time wanting to provide very good building environment for their for the employees. If it's an office building they are building, or if it's a mall, they want to have customers, so visiting people, having a very good feeling, but at the same time they want to save energy, and so they always will ask a design consultant to provide design. Now, the design consultant here in Asia are providing interesting design, The only thing is, I think this is a little bit our problem. So I'm speaking now as Sauter employees. So Sauter is a BMS company supplying BMS from Switzerland since more than 100 years. We started in 1910 and BMS in 1935. So we have quite a lot of experience, but we are not sharing enough of what are our technologies and what we are able to do. In addition to that, today with IoT and cloud solution and everything what's coming at the same time from each and every places, there are so many noises on the market that it's very difficult to find a design which will be tailored for a building based on all those noises, taking all of them together. And for me, the second problem we have on the market is the customer. As a BMS supplier, our customer is a main contractor, right? So you have a main con or a mechanical contractor who's going to reply to that particular new building which is being created, and he will try to provide the let's say the cheapest solution. Maybe that's not a good word, but let's say the price advantageous solution for him, because at the end of the project he's going to leave the project, and that's totally normal. I mean, this is not a charity company. They are doing business as everybody else, and they are trying to find ways to do profit, and this is normal, and this is how it should be. However, the only thing is he is not concerned. So he is concerned about definitely the quality of the product that he's going to install, and how the company was going to install it. Is this company capable of installing it? But there are a big question here. Is like, how much energy is your building you're going to use in the end? Is your building going to be efficient? All these questions are not interesting for a main contractor. It doesn't make any sense, right? Because they are not inside of the building. And when I came into Asia as a BMS supplier, I was like, oof, this is never going to work. I mean, we have so many new technologies coming in. And so that's why I wanted to bring this topic to you. So what I see here in Asia and even in Singapore, I must say, I was very surprised that today a BMS is focused on management of a plant room. And even a green mark standard. If you see a green mark gold building, the only things which are required is you to have a smart chiller plant room. I can give you an example. So I took these examples. So those numbers which I am showing you are from real projects. However, I slightly modified them so that there is absolutely no issue with the company who provided me this. And in addition to that, I will not disclose from which building it was. However, those numbers are real. So a company, right? A company which has its own building is using, in those months, you can see this is the energy consumption from the chiller here in Singapore. We had in August 2020 around 300,000 kilowatt hours. And September 310, 330 in October, November 335, December 335, and January 340. Now, I'll give you an information. This company was working standard during this whole 6 months based on the COVID-19. This was not having any impact on the building occupation. So the occupation in January and August was the same. So there was no difference here. Now, what you can see here is based on those information, you can see that around the same. So because plus minus 10%, right, is around the same energy consumption every month. Now, I took those data and I compared them with the average mean monthly temperature in Singapore. In August, we had 28.28 degrees Celsius, where in January, if you remember, January this year was pretty cold for Singapore. And we had a mean temperature of 25.98 degrees Celsius. So we are basically 2.5 degrees Celsius below the temperature of August, even though we used more energy, 10% more energy in that building for the chillers this is with the same amount of people inside of the building. In addition to that, we can compare how many working days they had per month into that building. So I checked also, this is data from Singapore based also plus on their holidays, because they have closed the building for 9 days in December, because stop of production for 9 days. So basically we had, instead of December, which was a special thing, but if you compare January 21-day working day and August 21 working day, so we had the same amount of working days. So what you can see here, you see this is a green mark gold certified building. So how can a BMS provide this kind of values? This is wrong. We have a very big problem here. And even though I would say, if you see December, which has a little bit, even the temperature was less than the average temperature in August, but even though with 9 days, or let's say only 15 working days compared to 21, we had the same energy consumption. For the chillers, there is also a problem here. So very quickly, I can also show you the same in graphics, where you see that those two graphics, the two lines, the mean temperature compared to the energy consumption, same. The working days compared to the energy consumption have nothing to do with one another. And based on this, we can draw a very clear result. So the energy consumption are not related to neither the amount of people inside of the building nor the outside temperature. And so based on that, we can tell you very clearly that there is no connection between the demand and the supply. So in a building, actually, now there is energy. Energy is one point, but energy is not everything. A BMS today should be able to work on your energy consumption, as well as to manage your building workspace. Your building workspace means that the BMS should be giving you some information as well on how much workspace do you really use? Do you still need that many square feet, or can you reduce, or do you need more? And it should also help your people to work more efficiently. Then when you compare this, and this rule is not coming from me, this screenshot is from JLL. So this is a JLL study. And they provide you these smart building rules, which they call 330-300. So if you can save $3 in energy, you're going to be able to save $30 on the building space, and you're going to be able to save $300 by making your employees more efficient. Now, how a BMS can do that? And now I'm going to show you some technologies. So firstly, let's go to energy management. How do we save money on the energy aspect? So the first one. So here, what we are doing, it's very simple. We add 3 types of engineering. We have the reactive engineering, proactive engineering, and predictive engineering. Now, what does this mean? This means that we are taking care of your BMS, of your chiller plant, as well as all other elements inside of your building, to manage them all together and create 3 different actions. The first one will be the reaction. Reaction means if now my temperature inside of the room is getting too high, I will increase the cold supply. However, if it's getting too cold, I will reduce the cold supply. Now I'm going to ask you the question, because I'm having this right here, right now. When I am in my office, here in the office I am, on the Friday, there are only few people inside of the building, because working from home and because it's Friday and so on and so forth. It's extremely cold. Friday is very cold day here. So on Friday, I take a jacket to go to work. But on Monday, actually, the temperature is quite good. It's quite pleasant, like 24, like very, very okay. So now this is the reaction. So we are speaking about the reaction already is not implemented in that building where I am. And I can tell you this building is very new, and it's the city center in downtown, and extremely nice building. And we are here in Singapore. So this is the first thing which is already missing for me. We have certainly a green mark gold or platinum building here with a chiller plant room, which is extremely well maintained, but working depending on start time every morning at 8 a.m. at 100% or maybe 85% whatsoever, and stopping at 5 p.m. and or 6 p.m. and so on. And this is how it's going to work. And if there are a lot of people or not, nobody cares. Same, we have no proaction. Proaction means that now that we have already a reaction based on the temperature inside of the rooms, we should add some proaction. Proaction means that depending on what is going to happen with the weather outside, I can start to cool more or cool less. I'll give you an example. If now I know that in 1 hour from now it's going to be cold because it's going to be raining and it's going to be a night and very dark and there is no sun, and right now the temperature inside of the building is good, then I can already stop one chiller, maybe start another chiller, which is a smaller chiller, and reduce my air supply from AHUs, or increase the amount of fresh air coming from the outside, because the temperature is not going to raise up, right? Same happens with the opposite, right? If I know it's going to be very hot, I can pre-cool a little bit so I can have a straight line inside of my building, because you don't want your building to warm up from the inside and then you have to cool that. That's going to use a lot of energy. Same happens with predictions. Now, a lot of people are speaking about AI. They say predictive control is called AI. Whatever you call it is the same. I will show you in the next slide. So the first thing which I wanted to say is that when we speak about reactive schedule, we should, and reactive action, here I'm comparing the demand and the supply. The supply, it means the supply of cold is coming from a chiller, which is here on the left. This supply is going to provide water, cold water, to my cooling coil. This cooling coil is going to cool the air, which is going to go through and going to go into the rooms. Now, if I have nobody inside of the rooms, I do not need to have a lot of cold water coming to my coil, so I don't need my chiller to be working 100%. So this should be working on calendars, on holidays, things like that, but also on presence detection. Now, in addition to that, what we add when we have a real BMS in 2020 should be working like that. Let's say we have Mr. John going in an office. So in an office, we should have several modes of working. So we have the economy mode, and we have a few sensors, which I'm going to explain in a bit. So let's say it's now 7 a.m. Mr. John should be working at 7 a.m. He's a Swiss guy. He comes to work very early. So Mr. John should arrive. So the schedule is on presence, right? So we have a schedule. We spoke about it before. However, because the schedule is on presence, but Mr. John is not in the room right now because the kids were sick, and he had to bring them to the doctor this morning to see what they've got. And so he had a little bit delay. He will arrive only at 8:15. However, because the schedule was already on, so we start the AHU, we start the FC, whatsoever he's got in his room, but we put it to the pre-comfort mode. So we just will do a little bit of cooling, so to pre-cool the room, so that when Mr. Jones arrives, the room is going to be cool already. But we don't have to waste 100% of energy, by providing 100% of cooling when Mr. Jones not even detected inside of his room. Now, 8:15, Mr. John arrives, is being detected in his room, and then we switch now the mode. We detect him inside of the room, then we switch the mode to comfort mode. And that time, now we can start to pull the full air. Mr. John feels good, he feels well, he has a lot of air blowing through his face, so that's a good feeling for him. He likes it, that's fine, no problem with that. However, Mr. John's gonna go for lunch, right? So 12, Mr. John's gonna go out for lunch. Mr. John's not detected anymore. So we stop automatically that air cooling and we go back to pre-comfort mode. So we will reduce the amount of cold air. We will keep the room at a nice and cool temperature, but we don't have to pull out that 100% of blowing air. Now, Mr. John's back from the lunch. He's been detected. Awesome. We go back to the full comfort mode and we're blowing again. Now, Mr. John wants a bit of fresh air coming from the outside because he wants to have new air. So he's opening the window. There is a window sensor. Window is open. What do? We go to protection mode and we stop the entire cooling because it doesn't make any sense to cool the outside. It's not going to work. Global warming is still going on. So we keep it like this until Mr. John closed the window. Window is closed again. We go back to comfort mode until Mr. John goes home. So now Mr. John is going home maybe at 5 p.m. instead of 4 p.m. That's this time. So the schedule will go off. However, because Mr. John still detected, we keep everything started. Now, what I'm showing you here, this is a very standard way how a BMS should work inside of a room. And yes, we have presence detection. Yes, we have a window sensor. Today, a window sensor is not crazy. You can have wireless Z-Wave window sensor for around $10 on even on Amazon. So this is the kind of solution which we actually need to provide to be efficient in the energy saving. Now, that is a very basic thing. In addition to that, I would like to mention also something which is a very big issue here in Singapore. You know, in Singapore, most of the time you have mixing dampers. So you have air coming from the outside, air going out of the rooms, and this air is mixed in order to save energy, right? So basically in Singapore, this air, like you have 80% of air, which is coming back from the rooms, going down and going back into the rooms, mixed only with 20% of fresh air. Now, this is the perfect solution to keep your virus inside of your room. I know that some people will say, yeah, but with the filter so-and-so, yes, but with the ion production whatsoever, blah, blah, blah. Guys, there is nothing better than fresh air. There is nothing better than fresh air. So we should have some PID for those dampers, which should be based. So we should control those damper based on the outside temperature. Let's imagine it's early morning. It's not so hot right now. Let's use more of fresh air in order to clean the air inside of the building. And then later on, when the day is very hot, no problem. We can use the ion solution, or we can use 80% of recycled air. And as soon as it's getting a bit colder outside again, we can again try to keep more fresh air, like in the evening and something. So every day you would restore fresh air and kill all the viruses, even using a little bit of free cooling, depending on the temperature that you have outside. Yeah, so these are solutions which should be implemented for a BMS. And I spoke about machine learning, AI, prediction. So what is this basically? A standard BMS system should have this implemented. You have historical value about your set point deviation. So set point deviation means if I want to have 23 degrees Celsius inside of a room, and I actually have, well, as time goes by, so within a day, I have between 22 and 24. So this is my deviation of my set point. So I know how I should deviate from my set point to make sure that my set point will be achieved. Same with the cooling inertia. Let's imagine right now, it's beginning of the day, I started chillers, and I have 25 degrees inside of the building. I want to go down from 25 to 23, and I know how many people are inside of the building. This is the inertia of cooling, right? I know with chiller and AHU running 100%, I'm going to need 30 minutes. Let's imagine 30 minutes to bring those 2 degrees Celsius down, right? So this inertia, when you know this data, when you know the heating inertia that you're going to need if you have 35 degrees Celsius outside and the sun blowing on the surface of the building, then you know how much time it's going to need to warm up. Then you can take this data to do predictive controlling. Predictive means I can predict. So this is what AI does. It's algorithm working to predict what's going to happen inside of your building and to take actions before it even happens. As example, Friday evening, 4 p.m., people going to leave the building today, right? At 5 p.m., right now it's very hot. It was raining before, becoming very hot. Normally, I should start a chiller, one chiller more, increase the amount of cooling. However, because I know that my heating inertia will take more than 1 hour to warm up from 1 degree Celsius, that all the employees of that building are going to leave at 5 p.m. because it's Friday, and Friday at 5 p.m. we have the history that people are leaving, then I don't have to start the chiller, right? This is very simple example based on predictions. Yeah, also you need energy management, and this is what a BMS should do. A BMS should not be just like what you see on the screen, just bars and your energy consumption, what you had for over the last few hours. This is what a BMS should provide you as information. The graphics that you see here on the screen, these graphics, I don't have time to go deep in details, but it should not be just like a bar graphic. This is like 10 years, 20 years ago. Now we have to evolve a little bit. These are the technology available to understand your building. As well, now a BMS system should provide you assets and maintenance management. Some people would call it a CMMS. So basically what's important is that you have a ticketing system with your maintenance system, that you have reaction maintenance. So we create a ticket if something goes wrong inside of the building, somebody receives an SMS and has to go do the job. Inside of his SMS, now we have IoT solutions. So that means that guy going on site receives an SMS, he takes pictures of the job he's done, and that's going to be uploaded directly on the maintenance system that you have online. And you can follow what has been done. Has the job been executed properly? I've been gone to project where I've seen in Singapore, I have seen an AHU with a filter never cleaned over 20 years. It was crazy to see that filter. There is no air going through that. There is no air going through filters like that. But the guy said, oh, I always paid my maintenance. He never knew what they've done. He never even knew what they had to do. So when you have a system which is tracking that for you and giving you these informations, then you can track and find out, hey, has things have been done properly or not? In addition to that, occupant efficiency needs to be improved. Each occupant of the building needs to have access to the building functionalities based on what they got to do. As example, as you can see here on top of the screen, we have the finance management. They want to have access to how much energy have been used in the building, just to compare with the bills they got to pay and see if, return on investment, if they have invested for any changes, if this is happening. That is normal. Also the value of their building. Now, if I am in a conference room, I want an iPad or whatever, I can change, values and stuff, to change scenarios, to go into presence mode or presentation mode, things like that. Definitely, you want to be able to book your meeting rooms and stuff like that. But if you are a caretaker or if you are managing the system, as a technical maintenance guy, then you want to have access to the system, understanding what's the BMS. This nowadays can be provided with one single tool, and it should not be provided by 20 tools which are not discussing with one another, because this is when you're going to have problems. And this is standard example. With this, I'm just going to jump on this one because I'm just going to show you some example. You are pretty familiar with what I just told you. However, nowadays, a BMS is able to provide you even more functionalities. Now we have smart workspaces. Smart workspaces means that you want to be able to work in a building where you don't know where your office is going to be, right? Maybe today I'm going to work on the office 69, tomorrow is going to be the office 52. So what you want you want to have an application where you can receive the attribution of your office. You can have a navigation system telling you where you gotta go to find out your office. Same, once you are in your office, you will be detected inside of your office, and you are able to change the lighting, the temperature, and things like that on your phone, on your office, right? And obviously not from the neighbor's office, because he maybe wants a different temperature. These are some example of graphic we have done. Even when you are, as example, in a building, so you are in your room, and maybe that's not a room that you are using often, you want to know where are the closest toilets, you just click on toilets, and automatically you're going to have a navigation inside of your phone telling you, hey, you just take the next on the right and you're going to be in the toilets. Same happens for your parking. Can I find my car? Where did I park my car, actually? Also, where is the closest meeting room? Everything is in German. Sorry, we've done this in Switzerland and Germany a lot, so that's why my screenshots are in German. But anyway, you understand the concept. And this is what a standard BMS can provide. I did not see that in a lot of standard specs lately, So this is where I'm quite afraid about what BMS is understood in 2021. Now I'm just gonna finish also with building efficiency. Definitely room booking system, presence reservation. These are stuff you are comfortable with. This is something I've already seen. It should be more and more present, in my opinion, though. And the last one, which I just wanted to say, is the what we call the smart space. Smart space includes smart toilets. Now, with IoT sensors, you have the ability to have a sensor, a wireless sensor, which is positioned on each, on the soap, when you receive when you take some soap, or when you take toilet paper, and the janitor is going to receive information before that it's the end of the soap, or before that this is the end of the toilet paper, so that we can send some people to change it. So you are making your maintenance team more efficient. The same happens with sensor that you have nowadays. Nowadays, a sensor can have a lot more information than only temperature. We should have CO2, air quality, volatile organic compound, but as well, we are providing noise detection. Noise detection is good for wellness. You know if your employees are in the wellness, but as well, if you have guarding system, as example, if there is noise in a building which is closed, then you know that something's wrong happening, right? So you can use your guarding security team to do only job when they have to go on site, and you can have more sites shared over the same team. Same for fire safety. With detection of CO2 and things like that, we can improve how firemen are working, and we can have them working faster. And the last thing which I wanted to say is, with those cameras that we have, so these are sensor with non-intrusive cameras. So these are camera providing only an X and Y value to say where people are situated. And based on that, you should have in your BMS now a floor display should look like this, where you know which office is used, which meeting rooms are used. Even if you don't have flexible office spaces, meaning that everybody has a very fixed working space. You know how many percentage of the time is this office used. Does it make sense to change to offices which are flexible, because you could have maybe rent 70% less space inside of your building? Or do you have enough big meeting rooms, because you can see that your meeting rooms is always full, and that the small meeting rooms, most of the time, there are at least 2 or 3 meeting rooms which are empty, the small ones. So should you merge 2 of them to make a bigger meeting room? So there are a lot of information that you can get with not only the live data. What's interesting is the aggregated data and historical data about your workspace. How is your workspace working? How is it efficient for you? So basically, I'm just going to finish with saying that the real building automation started in 1980. So in 1935, it was the very beginning. We started, as example, with Souter. It was like in 1974 that we started with our first software BMS, but the real BMS world started in 1980. Then in 2010, the smart building has started when we have added internet, we have added, you know, forecast, weather forecast and stuff like that to improve the way that building were working with proaction. In 2019, the ubiquitous building we're working where we add AI, so ambient intelligence, you can call it artificial intelligence, whatsoever you want to call it. And then now 2021 onwards, we have now Industry 4.0 IoT, building IoT, which is called BIoT, smart home IoT, whatsoever. So this is now how a building should be. And yes, we are still seeing too many times just simple building automation buildings. That's what we are seeing right now in Singapore. And when I discuss with people, they are always afraid of capex and low ROI, or how can they manage those ROI. And this is why we have created beez-fm. beez-fm is simply working as a BMS supplier, as you have Xerox working for a printer. You don't buy a printer nowadays. You're just going to rent it. Depending on the amount of paper you're going to use and the amount of ink, you're going to pay just a monthly fee, and you have peace of mind. Everything's going to be taken care of. Same happens for your cars. You don't going to buy a car, you're going to lease a car with insurance, reparation, and everything. And actually, for BMS, we are doing the same. Now we have cloud solution, IoT solutions. We take this inside of the new world and we provide a cloud where we connect all your building inside of your system. You're going to just pay a monthly fee depending on the tailored solution that you need for your customers and for your, let's say, building users. All right. So if it's a mall, definitely you don't want to have the same thing as if it's an office, and so on and so forth. Now, right now, you have huge energy expenses, a lot of manual actions required. The BMS definitely is not providing all the functionalities as it could be, and just, there is no refurbishment capex for all of that. Then we propose this solution, as I told you, which is BMS as a service. It's a rent to own model. So you, at the end of the contract, 3 to 5 years contract, everything's going to be yours. And we provide a design and we tailor the solution as well. So there are absolutely no cost. And at the end of the day, we guarantee energy savings, but a whole lot more of savings are going to be there. And what's very important is that we are also training the team, the facility management team, which is using the system, so that at the end of the day, they will be able to use the system. All right. So basically, that was it for my presentation part. Yeah.
Nico, excellent. Thank you very much for your excellent and very informative presentations. Highly appreciated. We'll just switch the view here now. Ladies and gentlemen, please refer to the right-hand side of the screen. We do have a couple more poll questions. I see that some of you have already started to answer, which is great. And I think this would be an ideal point to address those and just see how those results are looking. So Nico, your second question to our audience today was, in your opinion, is smart space management something that you see as either needed right now, will be more and more required in the short-term future, or will be required in the distant future? I'm pleased to say you won't have to wait too long. Pretty much 45% split between, 45% allocated to needed right now, and also to something that will be required in the short-term future. Would you care to comment on that?
Yeah, so I do totally agree with those answers, and I'm very happy to see that. And this is where we see the very big difference with what's really happening in the real life. As I said, I'm in a building which is 2 years old at most, and we are far away from being there. So I've seen some tenders coming out right now which are having this kind of design, but still not. I would say that we have too much noises from all solutions coming from here and there to have a very standard design which is provided today for all tender specs coming in that fashion. So yeah, but I'm very happy to see that actually people are thinking that they would need it now, or at least in the short term. Yeah.
Absolutely. And then our third question, if you would like your building to integrate the latest functions such as smart space and smart toilets, who would ask for the design? The options you gave were usual design consultants, IoT specialized design consultants, or BMS supplier providing advanced technology. There's a bit more of a split across this vote. Almost half of our audience voted for IoT specialized design consultants, almost 40% for BMS supplier providing the advanced technology, and then 14% for your usual design consultants.
Right. Okay, that's a very interesting one. I wouldn't have expected this. Definitely, it's good. Looking for IoT specific or specialist design consultant. The problem is there are only too few right now on the market. That's my understanding. I've discussed with a few design consultants who start to work into that, but still they are building up the knowledge right now. So I hope to see that being developed in the future. I'm actually extremely surprised to see that the second one was to ask BMS suppliers, because I felt that this is, being a little bit, we are maybe not asking the real companies who are providing or creating those solutions on the market, and this is maybe a surprising point that you guys are asking for them. So that's good. Yeah, definitely.
Great, thank you very much for that. We have a couple of questions come in from the audience as well. This one's a three-parter, so I'll read it all together, but let me know if you need me to repeat anything. Sure. Would digital twins of buildings have use cases additional to those already shown in this presentation? Should 2021 BMS have digital twins of managed spaces? If yes, what extra should they do?
Yeah, okay, so digital twin is a very good question, actually. So digital twin is, so what I was presenting has nothing against or with digital twin. Digital twin is more about how do you realize your project. So digital twin is you have a twin of your building that you have, we are using for this the beam modeling, and based on those beam modeling you can generate a digital twin of your building, and based on that you can calculate how much energy you're going to use. You can also improve the way of construction and things like that. So basically, yes, a digital twin in 2021, in my opinion, should be something that we should always aim for. The problem which I can see is that the digital twin has some, let's say, okay, the negative point of the digital twin is that when you are constructing the buildings, some suppliers, maybe window supplier or some specific supplier, which are like coming from the artisanal point or aspect, they will have maybe issues to provide beam modeling, so to make sure that they are working together with your digital twin. But definitely, yeah, digital twin, we have to go into that direction, and this is only a help for the BMS, and the BMS should be using the digital twin to improve your building.
Perfect, thank you very much. I hope that's answered the question there. We have time for one more question as well. Will you be able to share a real common example of a case whereby predictive maintenance is being flagged out using this kind of system?
Yeah, right. Okay, sure. So basically, predictive maintenance is, okay, some people would call it AI. Basically, that these are only algorithms. There is always a very simple example which I can provide easily. Anyway, what we want to achieve with predictive maintenance, you want to be able to act or prepare your actions before that something bad happens. So I'll give a very simple example. If you have a valve, this valve has a control actuator to control it, you know that this actuator, based on the data sheet, is able to do 50,000 cycles. Let's imagine 50,000 totally open to totally closed. Now this, if you have a predictive maintenance system, it will calculate how many cycles have you done till now, how many cycles per month in average and things like that, and be able to calculate when you're going to reach those 50,000 cycles. Based on that, it can tell you, hey, within 6 months, you may have to change that particular actuator. So it's better you can prepare to have your spare parts, and then you're going to be able to change it whenever it breaks. What we want to avoid to have a room or an entire working space where you have no cold air supplied because you have a failing actuator. So you want to know it before. Now that's a very simple example of the predictive maintenance, but they are a lot more complicated, with filtering and with engines with vibrations, stuff like that for motors, engines, and things like that. Yeah, to also improve and allow you to change things before they fail.
Excellent. Thank you very much for that. Well, that pretty much wraps up our time now. So thank you, Nicholas, once again for being with us. Really do appreciate that. There is one more question that has come through again. So we will redirect those to you, Nicholas, so that you can reach out to the person who has asked that. And of course, as well, they are exhibiting. So please do go and check out their digital booth. And you can connect with Nicholas directly as well if you would like to have personal conversation to ask any questions. In the meantime, please stay with us for the next session, which will be starting imminently with Camfil Singapore. As usual, you can access the next session by clicking the next button at the top of your screen. Nicholas, thanks again for your very informative session. Pleasure to have you with us again, and wish everyone a pleasant rest of the day and evening. Thank you very much.
Thank you very much, everyone. Highly welcome. Have a nice day.